So now we'll see the next concept, inverse variation. So as the name implies, if one variable increases, the other decreases, or if the one variable decreases, the other variable increases, provided the work is constant. So in direct variation, when variables vary directly, in inverse variation, variables vary inversely. Say for example, two variables, we take men and days. So here time taken is given in days. So if there are 3 men, work in 10 days. So now time taken by 6 men to do the same work. So if 3 men can do the work in 10 days, more number of people if there are present, so number of days will be half. So here double the men is given. So if 3 men can do the work in 10 days, to do the same work, so double the men is given. For 6 men will take half the time taken by 3 men. So if they can do in 10 days, 6 men can do the work in 5 days. So here men is in the ratio 1:2, time taken will be in the ratio 2:1. So they vary inversely. So whenever you know that they vary inversely, this parallel products will be same. So here 3 men, 10 days. So for the same work, if the men are double, time taken will be half. So here the products of first row and the second row will be same. Or the parallel products will be same. So 3 into 10, product of the first row is 30, and for the second row also it is 30. So whenever the variables vary inversely, the parallel products will be same. So by having this concept, so whatever is asked, you can find by equating the product of first row and the second row. So you can remember, like whenever the variables vary inversely, so you have this letter I for inverse variation, and this I has two parallel lines. So remember that this parallel line product, so parallel products will be same. So for this I, parallel product. So we saw that for direct variation, cross products was same. So remember the letter C which occurs before D for cross products, and for inverse variation, parallel products, the parallel lines which I has. So using this mnemonics, you can easily find out whatever is asked. So but the thing is, you have to find whether the variables vary directly or inversely. So in some questions they ask, if 3 men can do a work in 10 days, 10 men in how many days? So if 3 men can do a work in 10 days, so 10 men can do the work in 3 days, because product of this 3 and 10 should be equal to product of this 10 and number of days. So 3 into 10, so will be equal to 10 into days. So no other way, you should have this 3 days here. So if 3 men can do a work in 10 days, 10 men can do the work in 3 days. So now we'll see this concept by working out a question. So using the inverse variation concept, that is the parallel product is same, we'll see how to work out this question. So the question is, if 24 men can do a work in 15 days, in how many days 8 men can do the same work? So we'll see the working. So in this question, you have two variables, men and time taken. So time is given in number of days. So 24 men can do a work in 15 days. So you are asked to find, to do the same work, if 8 men are there, how many days will be needed? So when number of men decreases, time taken will be more. Here these two variables vary inversely. So when the variables vary inversely, parallel products will be same. So that is 24 into 15 will be equal to 8 into D. So equating this, you can find the number of days. So but whenever they vary inversely, as the parallel products are same, so instead of taking and writing, so just you draw a line between the two rows. So if you have common factor, simplify. So 8 and 24. The remaining numbers are 3 and 15. So product is 45. So as these variables vary inversely, parallel product is same. So for 8 men, they need 45 days to do the same work. So here the logic is less number of men, more number of days. So for 24 men, they need 15 days to do a work. So for 8 men to do the same work, so as they vary directly, parallel products will be same, and we have got the answer 45 days. 8 men need 45 days to do the same work. So we'll see another example. So example 2 for inverse variation. 5 men can weave a silk saree in 60 days. If the weaving of the saree has to be completed in 25 days, how many men should be employed? So we'll see the working. So in the previous example, we were asked to find time taken by a certain set of people. Here, number of days is given and you are asked to find number of men has to be present. So using the same logic, as men and days varies inversely, the parallel products is same. So we can find the number of men needed. So in this question, you have again two variables, men and days. So time taken here is given in days. So 5 men can do this weaving in 60 days. So if it has to be done in 25 days, so number of days is given. So for the same work, it has to be completed in 25 days. How many men should be present? So when time is less, you need more men to complete the work. So again this varies inversely. So to find this men, this parallel products will be same. So for inverse variation, this parallel products will be same. So just draw a line in between these rows. So we have the common factor 5 and simplifying 12. So 12 men are needed to complete the work in 25 days. So by using the concept of this parallel products, we have found that to complete the work in 25 days, we need 12 men to do the work, same work. So here the logic is more men, less days, and we need to do the work in less number of days, so more men are needed. So these variables vary inversely. So using the parallel product concept, we have found number of men required to complete the same work in 25 days. Here the answer is 12. So we'll see some more examples where the variables vary inversely. Say men and time taken. So for a given work, so if there are more men, they will take less time if it is given in days or hours or in minutes. So we saw an example based on that. So more men, time taken is less. So both men and time taken varies inversely. And days and hours also varies inversely. So if they work for more number of hours, time taken to do the same work, number of days will be less. Say for example, so you have hours and days. So if they are working for 2 hours per day and they complete the work in 10 days. So to do the same work, here the work is constant. If they work for more number of hours, that is if they work for double the time, 2 hours per day, so the same work will be completed in half the time taken. So it will be completed in 5 days. So here they vary inversely, so the parallel products will be same. So 2 into 10, 20, 4 into 5, 20. Your number of hours is in the ratio 1:2. Number of days will be in inverse ratio 2:1. So days and hours also varies inversely. The same way, efficiency and time taken also varies inversely. So to do a same work, if a person is more efficient, he will take less time than a person who is less efficient. So efficiency and time taken also varies inversely, and you can use the parallel product concept to find whatever is asked. So now remember friends, for direct variation, remember the letter C, their cross products is same, and for inverse variation, remember the letter I for inverse, and here C, the letter before D. For inverse variation, the letter I, where you have parallel lines, parallel products is same. So we'll see the next concept.